So, welcome everyone to this wonderful model evaluations hackathon. Thank you everyone for joining us online and joining us across the world at 5 different locations at the moment. We have the pleasure of welcoming Marius Hobbhahn of Apollo Research fame, and he's the director of that organization and has been doing a lot of work within interpretability and now working on, and he can of course expand more, but working on evaluating deceptive alignment within models, and I believe it is also using interpretability. So let's welcome Marius to the stage and hear what he has to say.
All right, I'll just assume people can hear me. Um, yeah, so this is not going to be that long of a presentation. I'm just going to try to answer like a couple of high-level thoughts. I have about evals, maybe like 10 minutes or so in total. And yeah, you can go to the next slide. So the first thing that I have realized over the last couple of months or so is that evals can mean a lot of different things, and it will definitely be the term already doesn't mean that much anymore. As in, evals is kind of being used as a kind of whenever you measure something in a model, it kind of already fits the term evals, and people in politics and governance especially are already using it for like a lot of random stuff. Companies have picked up the term model evaluations, and and I think already like meaning is kind of lost. The way I think of, to some extent, the way I think about it, oh, there's an L missing, is the systematic measurement of safety relevant properties in neural networks. And this can include, like mostly refers to behavioral evals. So you only look at input output behavior, but it doesn't need to. So you can add white box tools to model evaluations as well. For example, you can test behavior and look at the internals. But the core thing is that you're systematically trying to measure a safety relevant property, so that the result of this is kind of like a benchmark or some way of saying, okay, we systematically tried to measure this, and this is our result. This is what we learn about the network now. Then one difference that I feel like is worth pointing out is there, at least in my head, there's a big difference between red teaming and unbiased model evaluations. With the way I think about red teaming is basically you take a model and you interact a lot with it, and then you try to find flaws in that model. So there's a lot of interaction going on while you basically design your red team. So they cannot really be the eval cannot be disentangled from the model. So like dependent on the model, you choose different strategies. And if you were try to, let's say, find deception in different models, you would probably use different strategies for different models because they act in different ways. And then there are unbiased evals where you try to minimize the amount of interaction between the eval and the model. So you would try to basically, like in the perfect case, right, you would come up with the eval before you run it on any model, and then once you're finished with the eval, you run it on all the models and compare it. So to try to minimize the bias you introduce into the model evaluation. And I think right now, kind of most people are doing some mix, like something in between. Like maybe you try to build an unbiased eval, but you still go back and forth from the model like a couple of times because you realize actually the questions I asked are already too easy or like too hard, or they have some other problem that the model is like doesn't understand them, and they have to be rephrased and so on. So like what people are doing is mostly in between, but I think there will at some point be a much clearer distinction, and I think we kind of need the unbiased evals at some point if we actually want unbiased results. So yeah, this is just like categories in my head. And then there is a difference between capabilities and alignment evals, where the capability evals I think of as testing whether a model can, in theory, do a specific task or a thing or has a specific property. So it's kind of like an existence quantification. It's like, can I find at least one scenario where the model, I don't know, is able to do to be deceptive or to lie or something like this. And then there are alignment evals that are making a statement about tendencies. So how often does a model behave in such a way in a representative sample? And the problem with the alignment evals, and I think this is like a very open research question right now, is like the statement you actually want to make with alignment evals is on every possible situation, like how often does the model behave in the aligned way and in the not in the misaligned way. And the problem is we cannot enumerate all possible situations. So kind of the statements we're trying to approximate this by finding a wide range of representative inputs. But given that text is so vast, yeah, I think alignment evals are just kind of flawed right now. We don't really know how to do it. And I think like my takeaway from this basically, I think it will take until we have good interpretability tools before we can make more general alignment eval statements. But yeah, it's worth trying already. But definitely, if you decide between doing capabilities and alignment evals, capabilities evals are much easier right now. All right, can you go to the next slide, please? Thanks. Yeah, so the other question is maybe on a high level, like why do we care about evals in the first place? And the way I think about it is, or like when we make decisions about these AI systems, about deployment, about training, about whatever, monitoring, about who gets to use them and so on, like right now at least, we're making these under extremely high uncertainty. Often, like GPT-4, right? Or GPT-3 has been released like many months back at least. And still people like with GPT-3, maybe people are not finding that many new things anymore. But like 6 months after people released GPT-3, or OpenAI released GPT-3, there was still new capabilities that were found by like random people on Twitter. And so we didn't know what the model was capable of, or at least OpenAI didn't know what the model was capable of, and before releasing it. So that makes these decisions very hard. And the basic thing that devals is trying to do is like getting a better understanding and scope of what the limit of the capabilities are, and then also the sort of average tendencies of the model in various situations. Then the other thing is, I think evals are the least bad currently available technique to get this info. So I'm not like, despite leading the evals team at Apollo, I'm not that bullish on evals overall. Like I think basically evals are the best tool we currently have, and it's like really good that a lot of people are focusing on it right now. But in the long run, it is definitely not sufficient to get strong safety guarantees that we would need to make decisions about general intelligence or superhuman intelligence. And yeah, we would be interpretability, but we don't have them yet. But yeah, this is kind of the way I think about it, like the least bad currently available. And then one thing I want to point out as sort of limitations of evals that I also think is good to point out when you talk to policymakers or to other people who are like extremely bullish on evals is that there are like a couple of very fundamental limitations that I think evals will always have. The first is absence of evidence versus evidence of absence. So basically, with evals, you can only make statements about like, oh, I found, like, you can either make the statement, I tested it on a lot of data and I found a problem, or you can say, I tested on a lot of data and I did not find a problem. But you can never say, a general statement about this model will never have this problem. You can always only make a statement about, at least in the positive case, you can only say on the data I tested it, I didn't find anything. But you can never say on all the possible data, I didn't find the problem, which is very limited, right? You would have to have huge sets to sample like all the meaningful space, which you don't. And the second limitation is currently evals are primarily behavioral, so only input-output behavior. And then the last thing is it's typically not constructive. So like what you do is you're like, okay, I tested this capability or these alignment behaviors of this model. Here's a problem I found, and then deal with it, right? Like you're not making you're not saying how to solve the problem. You're basically just pointing out flaws, which I think is totally fine. It's very valuable, and it's good that this exists. But I think in the long run, this will, or like, yeah, it's like at some point maybe we find a ton of problems we don't know how to fix them. So it will definitely like need some additional thinking to then get to a solution that is working. It's like itself, evals is not a constructive approach. All right, last slide. Yeah, so the like one thing that I've been asked a couple of times now is like, how do you even start with evals? Like, it's sort of a like unclear what it means in the first place. It's such a like washy term. And my suggestion is just start measuring something you're curious about and iterate. Like, don't overcomplicate it. Do not, or like, you can obviously do that if you like, but you don't have to like invest a ton of time in becoming a great software engineer and like an ML engineer and know how to do the fine tuning and all of this. Just like if you know how to use the like GPT-4 playground, you're good to go. And that's kind of all you need. And I also think that it's like by far the fastest way for me to make progress. So like, despite me having some evals experience, if I want to start a new eval, the first thing I do is going to the OpenAI playground and just starting to like type in a bunch of questions and a bunch of different things and see what how the model responds, rather than like building super complicated theory first. Yeah, this is the other point. That's the second point I want to make here is like, in the absence of theoretical clarity, most progress comes from empirical feedback. So my suggestion would just be move fast with the empirics. Don't like, obviously you still need to think conceptually about what you're trying to measure and whether this is something to measure, like whether this is the right thing to measure in the first place and so on. Like, especially if you're new to evals, almost all of your learning comes from just starting. Like just doing stuff and hacking your way in. And then the last thing is we prepared some things for the hackathon as Apollo, which so there are two pieces of two Google Docs you can click on. You can also ignore them. Obviously, you don't have to follow our project ideas, but we would be interested in your feedback and also whether you if you choose them with the project, whether you like them or not. Yeah, so the two things are a starter guide, just for people who may be new, just like a bigger summary of what it's all about and how to get started, and then some project ideas or ways to generate good ideas for evals. Here I would, so they're somewhat focused on deceptive alignment because this is like the thing we've been thinking about the most. But some of the techniques also, or like ideas also apply to other fields. But yeah, that's all I have to say for today.
And a great message of let's build some emails. um, Now, anyone is super welcome to jump up on stage and raise their hand, and then we can invite you up to chat on this virtual domain we're in right now. And otherwise, thank you so much, Marius, for the talk. It was great to get a little introduction to your thinking processes around this. I guess I can already start with the first couple of questions. You mentioned this about not moving too quickly towards theory, but are there some directions you are excited about at the moment on theory, or do you think that it is obscuring the picture nearly no matter what you work on with theory at the moment?
No, like we are actually thinking about theory, but I think the question is like, who is the message addressed to? I think if you already have a lot of practical evals experience, you will have to think more about the theory, but like the best way to get to that position is to do a lot of practical stuff. The two things we're thinking about in theory, or like the two theoretical questions we're mostly thinking about are, one, what we call science of evals. Like, what is the correct way of measuring things in the first place, abstractly speaking, or like specifically for neural networks and specifically behavioral. Like how, like for example, what is the difference in the message you get if you do fine tuning versus just behavior, or what is the difference between different ways of phrasing the question? So for example, you could say a model, like either you let it act in a specific way, or you just ask it directly, sort of stated versus real preference type things. And they will give you very different responses. And the question is like, okay, what does this imply for our, like how we think about the model? So these are a couple of like science of evals questions. The other is just conceptual questions about the things we're trying to measure in the first place. So rather than asking like how do we measure them, etc., it's more, let's say, if you want to focus on deceptive alignment, what are even the core components of deceptive alignment? Like, is situational awareness necessary or not? Is like long-term planning necessary or not? How would we, like, what is the type of long-term plan, like assuming it was necessary, what is the type of long-term planning that we would want to measure? What is sort of the minimal viable piece of evidence that we could gain? These kind of more conceptual questions. But yeah, like if you're new to evals, don't think about any of this and just like start with an easy project and just get hacking.
Nice.
I had a question, particularly about you said that Apollo was doing research on trying to figure out like how to do evals correctly, effectively. I know that there's been some work, like for example, from I think David Mannheim recently published a paper on like defining evals more robustly, not just in machine learning, but also in general and for other applications. And I'm wondering what your thought on utilizing like information theory solutions, maybe like randomized selective sharing in order to obscure like gaming of the system.
Yeah. Yeah. Okay. So I think there are two questions in there, which is so the first one is like, how do we draw? Like, how do we learn from other fields? And my hot take here is basically evals. Like 90% of evals is just like taking stuff from other fields, like psychology, physics, biology, and so on, and just applying best practices on like new systems. But the measurement has been done. Like evals is really like the simpler problem, or like measuring stuff in NNs is really the simpler problem because you have way more control. So yeah, 90% of evals is just like reading the introductory textbook from other fields and kind of thinking about how it applies to neural networks. So that was question number one, and the second, oh yeah, randomizing evals and obscuring them and so on. Yeah, this is a question we're actively trying to figure out, like how easy is it to game an eval? And my thinking right now is that if you're a malicious actor and you have some information about the eval, it's very likely to game. So we are like still somewhat hesitant to publish our evals. Like if you publish the entire thing, people will just train on it and it loses all of its meaning. But even if you publish like 3 samples and an explanation of what you're doing, I think even then it's very easy to rebuild the eval. So a malicious actor definitely has like the ability, I think, to game the eval right now. But I don't really know what this implies yet. Like, yeah, we'll have to see.
Okay, interesting. Yeah, thank you.
No worries.
And go ahead, Hiram.
Thank you for the presentation. It was nice, short and sweet. Really quickly, you mentioned about like deceptive alignment and also like communicating this to policymakers. Those two things in my mind spark this. How do you make like evaluations sort of more continuous, so you kind of know and you can track whether like AI systems are gaining capabilities and like are becoming more deceptive over time, something like that. Because from the examples I'm seeing on the document and from like the short presentation, it seemed like evaluations right now like kind of like looking into the model at a single like discrete time step.
Yeah. Yeah. Good question. So there are a couple of ways. Like in the optimal case, right? We just predict it correctly. So we just run evals on like a couple of different models with different size and at different points in time and so on. And we just draw a line, and then we say, oh, at this point it's too dangerous. Probably we should like be really, really careful before we train that model, or just don't train it at all. I don't think that's politically feasible, but like, yeah, we'll see. So that's the perfect case. I think this is like unrealistic in almost all circumstances because we just kind of it's too hard to predict. Like we don't know how to draw the line correctly and to predict ahead of time where the dangerous line is. So yeah, I think this is going to be very hard. but so the other thing is you just want to rerun eval. Like once you have an eval, you kind of want to rerun it all the time, or like before any new model comes out, you want to rerun it. And you want governments to be involved with this. You want external auditors to be involved with this. It's like, especially before deployment. But so Lee, my co-founder, recently published a pretty long paper on auditing. And our conclusion was basically, if you're serious about auditing and third-party auditing and these kind of things in AI, you have to check at every step of the development chain. Like even before you start, you have to decide whether, or like you have to think about whether it's a good idea to train this model in the first place. And during training, you have to like reevaluate at various different points in time. Before you then fine tune, you have to like during fine tuning as well, et cetera, et cetera. Like just if you're actually serious about risk and you think and you don't have any theoretical framework to guide you, you just have to get a shit ton of empirical evidence, and you only get this by evaluating all the time.
Yeah, and I guess an extension to Hiram's question, thank you so much, is also to like, how do we reconcile this with the real world, and what do you see the future of evaluation moving into?
So a lot of people are moving into the eval space, and it's not just like safety minded people. It's also like an economic field. So at least some people think so, and therefore they're moving into it. And there are a bunch of startups that are basically just profit driven, which has its own perverse incentives. I think there's like a pretty big danger that that evals will just be safety washing at some point. So to answer the original question, so one, I think it would be great if there were just more government agencies like the UK Task Force or UK Air Safety Institute now that just have the intention of just running a shit ton of evals all the time, and like working with the labs and so on. So that would be good. And then just lots of external actors, like us, like ArcEvals, like others, also the for-profit ones, that just test a lot of things at like high frequency and so on. So maybe to give like a picture of where I think this is going, right? Like if you think about the cost of a training run right now, or like of developing a model, the biggest part is salaries. The second biggest part is compute. And in total, this is like a shit ton of money, right? I guess GPT-4 training was like, the final training one was maybe like 50 to 100 million. And then all the training runs before that didn't work, maybe 3 times that. And then $500 million of salaries on top of that, or something like this. And so you'll get probably to like 1 billion. And then evals in comparison was like, I don't know, 100K maybe, something like this. If you literally just, or like maybe $1 million, I don't know. If you take the inference, the cost of inference and some of the salaries and so on, it's like extremely cheap, like 1,000 or something in comparison. But if you look at pharmaceutical industry, for example, what they have is 90% of the total cost of like developing a new drug is testing. It's just like phase 1, phase 2, phase 3 trials. And I think, I basically think AI will go in a similar direction where like more like bigger and bigger parts become or like bigger parts of the cost, or at least time invested becomes safety, because we're now at a point where like capabilities are there, and really the thing that's stopping people from deploying is safety.
Yeah, makes sense. And we'll take the last couple of questions here. So you and then Jacob.
So I guess going to the limitations of evals, I'm not sure exactly how to form this question properly, but I guess thinking about the challenge of scalable oversight, evals are a form of insight, of oversight, and then we could say that like late game interpretability can also be used as a form of oversight. Are there other forms of oversight outside of these that you also think are like methodologically sound successors of evals?
Yeah, I mean, typically the scalable oversight schemes are like do not include evals and interpretability, right? These are usually treated as separate things, and scalable oversight are things like RLHF, constitutional AI, what's it called, debate, these kind of schemes. So yeah, I think all of these are like interesting ideas. I don't think any of them has like a pretty high chance of working out of the box. At least if you have very, very smart models. They also have some conceptual flaws. Yeah, I don't know. And like I think neither evals nor the other three that I just mentioned have like a pretty good chance of working out of the box. It's just too hard of a problem, I think. So I'm very much in favor of like a defense in-depth approach where you just throw everything you have onto your model, and even if many of these things are potentially redundant, and then yeah, you hope that you survive until you have sufficiently good interpretability tools.
Can I ask, I guess, another question?
Go ahead.
So do you have a like vision for like what the form of good interpretability tools might be?
I mean, I have something sort of, I have an ambition or like something where I want to go to. I'm not sure whether this is realistic or not. It's definitely something we are trying at Apollo. So basically, ambitious mechanistic interpretability. It is, I think, like you want to understand the full causal path that the relevant variables in the model are taking. Like you literally want to be able to trace the information from input to output all the way through the network in a causal manner. And this is very ambitious. It's like it hasn't worked so far. Everything we have is really like not very close to this. But yeah, I think if we had this, I would feel much, much, much safer. Even if it was quite compute intensive, for example.
So basically reverse engineering any decision through the network, or
yeah, like, and even intervening at runtime. Like you don't even have to reverse engineer it. You can literally trace it while it's thinking.
Nice. And how what's the percentage progress towards that, do you think?
I don't know. I mean, we're working on something. I'm pretty excited about it. But yeah, early stage. I can't really say whether it works or not yet.
I say we're about 40%.
Yeah, 30, 50. All right, Jacob.
Throwing a bunch of numbers.
Yeah.
Yeah. So you mentioned in the talk and also when you were answering a previous question about safety washing of evals, and I feel like this would be a really bad thing to have happen. So what are some methods or potentially some ways that Apollo has been engaging with, like trying to making sure that doesn't happen?
Yeah, many things we can try, I guess. So the first thing is, I think, just be like very honest when you talk to policymakers. Don't overpromise anything. Just like rather than saying, like, oh, we're this, like evals will solve everything, super cool, blah blah blah. You just say, it's like it's okay. It's like it's a good thing to try. It's like worth investing in. It's probably better than many other things that would otherwise be invested in. But also, it's like not it's like by no means sufficient. And policymakers get that. Like when I talk to them, most of the time they're like, oh yeah, that makes sense. Like, okay, we should also invest in interpretability and many of the other things that are being tried. Like I'm very much not trying to grab all the money for evals. And I think that would be bad. So that's one thing. The other is when you actually apply the evals to some of the organization's models, like make very sure that you're very clear in the message. So one thing that I think will automatically happen and will also like kind of happen to, so, like basically, if you're an auditor, you're going in and you're trying like a very specific thing with a lot of context and a lot of caveats. And if you have like 10 minutes to explain it to someone, they will get it. And then the lab has a bunch of PR people, and the PR people are like, oh, we got audited, right? The PR people are not technical. They don't understand the context. And also attention spans are extremely low. So what they're going to publish is like, our model is safe. It was audited by like a safety company. And the thing you actually did was like testing a very, very small particular thing that doesn't make any claims about like 99.9% of the behavior of the model, and it will definitely be distorted. So what you have to do as an auditor, or like at least the way I think about it, is you have to be extremely sort of conservative in your phrasings. Like you can never say like even hint at the idea that the model that you tested is now safe or something like this. You basically have to stay in very, very technical terms all the time, and conservative terms, to like make very explicit that you're not doing that. And then the last thing is, like I said earlier, right? I think there is a strong financial pull into into evals and auditing right now. It's just like it probably is going to become a profitable business model, and the business things are not always the safety maximizing, like the profit maximizing things are not always the safety maximizing things. So there will be a lot of people who are like going to lobby for a lot of random stuff that makes them money, but that doesn't necessarily improve safety, or at least not maximizes. And I think it's therefore very important that the people who are in it for the safety, like speak up early enough that they can say, okay, let's set a bar, like let's make sure that you cannot just like randomly claim a lot of stuff and say, oh, we audited something, please give me $1 million. Like there's like clear standards and a clear bar for what it means that you audited something in the first place. Which is like something we're trying, but it's still hard to set up.
Mm-hmm. Okay, cool. Yeah, thanks so much.
Nice, wonderful. All right, I'm sure everyone is sitting at home and clapping at the moment from your wonderful Q&A here and the wonderful talk. Thank you so much, Marius.